Welcome to a lesson with Dr. Powell. Let's review U substitution. How to do U substitution. It's backwards chain rule. Now, chain rule, if you recall, so thinking of something like this, sine of x squared, so one function inside of another. To take a derivative, the first thing you do is you ignore what's inside here. Like you put your hand over it, you cover it, and you think of this as being sine of something or sine of chunk. What's the derivative of sine of chunk with respect to chunk, where chunk is your variable? Well, naturally just cosine of chunk. And you fill in what the chunk is, but then the trade-off is you multiply by the derivative of the chunk, which is 2x, and that's your derivative. It's kind of like saying if this whole thing is y, then it's like saying dy over du, where u is your chunk, but then you multiply by du over dx. And notice kind of a nice intuitive cancellation there in a dy dx fashion to get your derivative. All right, so that's chain rule. So now we're just going to do backwards. Notice that the last thing we did was multiply by the derivative of your chunk. So the first thing we do is we divide by the derivative of the chunk. And that will allow us to integrate then with respect to the chunk. So quite literally, what we do is we just replace, see the dx in here means we're integrating with respect to x. So quite literally, we just cross this out and replace it with the idea that we have yet to integrate by u. That's the next step. But before we can tackle that, we have to divide by the derivative of u. And if you think intuitively, actually, if this were fractions with numbers, this actually is the same thing as dx if that was a number, if you simplify the fraction, if you thought about it that way. There are some technicalities with thinking about it that way, but however, it still does work. The d's would cancel, you'd be left with dx. But that intuitive notion helps the technique, and mixed with the technicalities actually gives us the result. But I'm not going to discuss those technicalities. So that's kind of what's happening here. We just replace that. So in general, let's take a look at an example. What if we had the integral of natural log x over x dx? Then what we can think is, notice that we see a function and we see its derivative kind of hanging out here in some kind of way. So what we naturally do, we think, well, what if we let this be the thing that you see that's derivative for hanging out? Let's let that be u. Then what you do is you just cross out your dx, replace it with du over the derivative of u, which is 1 over x. And magic occurs in denominator land. X times 1 over x, those cancel. So the denominator is just 1. You're just left with u. So u du. So you get u squared over 2 plus c. Replace what u is, which is natural log x. And we are successful at finding the antiderivative. Likewise, here's another example. What if we had we have x times the square root of 3x squared minus 2. What would we do? Well, notice that the derivative of this is a multiple of this, so this would be a good choice for u. And then the derivative of u would be 6x. See the cancellation? Bring the 1/6 out. The integral of u to the 1/2, which is 1/6 u to the, so we have add 1 to the exponent 3/2, but then divide by 3/2, which is like multiplying by 2/3. So, so we end up getting, and that's plus c. So we end up getting u to the 3/2 all over 9 plus c. And we can replace u with what it is, which is 3x squared minus 2. 3x squared minus 2 raised to the 3/2 all over 9 plus c. Thanks for watching.